In this video, we will try to use MATLAB Simulink to model this physical system and solve this ordinary differential equations, uh, which we will get from solving this problem. This is the problem that we are considering. This is a 2 degree of freedom spring mass system with a viscous damper and a spring constant. You can see the x1 and x2 are the coordinates representing the corresponding masses and their displacement along right hand side, and this force is applied on this mass is F1 and F2. So we first draw the free body diagrams of the corresponding masses, from which using Newton's laws of motion, and from which we will get the equations of motion. Here, as you can see, for first mass, the spring force and damper force is applied on the left hand side, and the force will be in the right hand side. Similarly, for mass 2, and the acceleration and displacement of the masses are along the positive x-axis. By applying Newton's second law of motion, we will get the equation of motion for corresponding masses. Since we have 2 degrees of freedom, we will get two equations with corresponding forces and mass terms and displacement and velocity. If for our Simulink model, we will rearrange this equation so that we will get second order differential equation, second order derivative on one side and other terms on the right hand side. So we have these two equations which we will try to solve using MATLAB Simulink. Let's get to the MATLAB Simulink. Here we have a model, a Simulink model, which I get from like this. Blank model. First, we will add an integrator. We will require two integrators since we have two second order derivative. I will copy paste this integrator and join this. So whenever we apply a second order derivative in this from as an input to this first integrator, we will get x dot. I will name it as x dot. And after applying integrator on x dot, we will get our displacement or x. I'll just type x. We'll require two such integrators because we have 2 degrees of freedom, that is two equations. I will copy paste these two and arrange side by side. Now let's get back to our equations. I will split the screen. Now, okay. So we have to apply, now we need an adder for these terms in the bracket. So I will add an adder, or let's first do this for second equation. For this adder, we have, here you can see for the second adder, we have plus, plus, minus, minus, plus, minus, minus, plus, plus, minus, minus, plus, minus, minus. I will increase the size. That is visible also. Easy to operate. Like this. I will join this. So this is nothing but our x double dot. That's why we arrange the equation in this format. So I will just name it x. What the inputs to this adder is this f1 sorry f2 c2 into x dot 1 and c2 plus c3 into x dot. We will apply them here, but we also need again to represent this mass 1 upon m2. So we'll also add again, and it's 1 by M2. Okay. This is showing this error because we haven't yet defined what is M21, M21. It will show for other gains also, but for now we just here. Okay, so we have gain. So let's create this equation by using other gains here. First let's add force, or I will set force as constant. Assign, let's just say F1. We will also assign the value to this here. Then we need a C2 into X2. So let's add again. Here, this is C2. It will represent our C2. Enter, and C2 into the first derivative of X1, where the first derivative of X1 is here. So we will join this output with this. Okay. Second thing we need is minus C2 into X plot. So I will just copy this C2 itself here, and it's into X2 dot. So that is this here. Then we need another gain, a new gain. This is C3. Let's add that gain and name it C3. Okay. We'll add it here. C3 into X2 dot. So same thing. Next thing is K2 into X1. So we need another gain. Name it K2. Okay. K2 into X1. X1 is the output of the first this first integrators. I will join this here. Okay. Another thing is we need another K2. So I will just copy paste this K2 here. K2 into X2. Okay. So X2 will be the output of this integrator. And we need new gain K3. Again, K3. K3 enter. Here. K3 into X2 again. So this is the same output here. Okay. The first block, or you can say the second equation, is ready here. We will do the same for the first portion. I will do this here and do that this. So we need another adder. Let's add an adder here with inputs plus, okay, plus, then minus, minus, plus, minus, minus, plus. Okay, and increase the size of it. Okay, now we need, okay, so sorry, here we have to name it as F2, not F1, and add a constant here, or you can just copy paste the constant from here and then change the name to F2. I will add a new constant here, F1. Sorry, F1. F1. Okay. This is the input to this first input. Then we need minus C1 into X1 dot. Let's add C1. Oh, sorry, that should be again it will we don't need that, we'll delete it. We need gain, not type C2 there, and name the gain as C1, because we haven't yet defined as C1 in the second equation. We don't need C1 in second. C1 into x, C1 into x1 dot, that's here x1 dot. Then we need minus C2 into x1 dot, or so I can just copy paste this control V, then drag here at this input like this, and this is C2 into x1 dot, so here. Okay, then again we need again C2, so just paste here, I already copied. C2 into x2 dot this time, so x2 dot is here. Oh, I think I should name this as x2 dot. Okay, x2, and what I will do, I will name this as x1. Okay. Then we need k1, k2, and again k2. So did we define k1 here? No, we need k1. Oh no, sorry, that's again the same mistake. K1. I will add this over here. K1 into x1 dot. Now, sorry, that should be x1. X1 here. Sorry. Okay, and then we need k2 into x1. We have k2 here only. Then drag and drop here. Then k2 into x1. Okay, and finally we need again k2, so I will just paste k2 and add k2 somewhere here, and the input will be x2. X2 is here. Nice. Okay, that's the two equations. Now the first equation will solve and give us x1. Let's name it x1. The second equation using this process will solve and give us x2. So to view the output, I will maximize the screen. With the output within oscilloscope. A scope here, I will add a scope. This scope should have two intakes, inputs. It will take time. Okay. Here, number of input ports are given to 1. I will set it to 2. Okay. Okay. So this, let's increase the size of it, and like this cursor and attach here. Like this cursor and attach here. Okay. Also, we need to define these variables. Not defined, we have to assign them a value. And we also have some initial conditions. First, do this initial conditions so that we can work only in this environment. Okay. The initial conditions are x2, x1. So x1 is here. So this integrator should be 0. Initial condition, okay, 0. Good. x2 here, it should be 1. We will assign the value 1 here. Then we need x1 dot, that is this integrator is 0, it is 0, and x2 dot also is 0. Okay, that's that. And now we will assign the values here, this value, that value shown in this table. So for that, go to the command prompt, command window, and let's assign m1 is equal to, so let's first of all let's check, do we have m1 m2? Yeah, I haven't. Okay, this was m1 upon m2. We need again here, so I forgot to add again for m1. So again, and I name it 1 upon m1. Okay, and the value of that gain is 2. So in command prompt, I will say 2, enter, should add a semicolon. M2 has value of 4. Then we have K1 as 8, K2 as 4, K3 as K3 is 0, and C1, C2, C3 also 0. C1 is 0, C2 is 0, and C3 is also 0. Okay. We assign them values. These variables have, you can see in this. You can see in this workspace, the values are assigned to these data pointer. Okay. Let's get back to the model and maximize it. Now let's first let's just run this. I guess we have to save this before running in progress. Maybe it will take some time. Compiling and ready. Okay, we have some errors. Okay, sorry. Yeah, okay. We haven't defined f1 and f2 yet. That's a mistake. We need to define f1 and f2. So here we haven't get any, we don't have any values here. We can assign some random values. Say f1 as 10 and f2 as say 5. Get back to here, and then I will run again. Hope this time we will not get any error. Initialization for okay, this time I won't give us any error. We will open the oscilloscope to see the results. It will take time, or probably yeah, open. So this is the result we get. So by okay, so this is running for 10 loops. Stop time is 10, so I will increase it to 100 and then again run it. Now you can see after 100 we set the increase this time steps, we get this solution. So this is a solution for this equation. The system, physical system was here, and we solve this physical system using Newton's laws, and we get two equation of motion as shown in this slide. We rearrange them as our convenience, and then we solve using Simulink with these initial conditions and this data as our input, and we get this graph of one of them is x1 and another is x2 graph. So that's the solution for the selected problem. Thank you.